Okay, next is control devices for gas contaminant from stationary source. For example, the gas contaminant can be in either SOx, NOx, carbon monoxide, and so on. So the treatment that we can use for gas is by using either adsorption, absorption, condensation, or combustion. Minimization of emission such as VOC, NOx, and SOx. So as we all know, VOC it can be either in liquid or solid that contain organic carbon which vaporize at significant rates. So VOC are toxic and carcinogenic and also contribute to the problem of global warming. So the control of VOC do not involve any changing of the chemical nature of the pollutants. So we can use by physically control. So in minimization of VOC, it can be done either by prevention, concentration and recovery, or oxidation. For SOx and NOx, that is basically coming from power plant and refinery and also transportation. So these pollutants are strongly respiratory irritants, okay, that can affect your health and also not only for human but also for animals, okay, at high concentration. So these gases can contribute to the formation of PM10, particulate matter 10, and also particulate matter 2.5. So for SOx and NOx, it can be reduced by absorption, stripping, and also wet scrubbing. And for NOx, it can be done by catalytic reduction. So first, look at adsorption. This is not the same as absorption. So adsorption is the addition of molecules of gas, okay, either gas, liquid, or dissolved solid to a surface. So you need to have medium for adsorption to occur. So the surface is called adsorbent. And so this process involves passing a stream of effluent gas through a porous solid material, that is the adsorbent just now. And adsorption of adsorbate on adsorbent can be either by physical or chemical. So if physical, it does not involve any reaction, but if chemical, it involves some reaction. Okay, look at the first one, which is physical adsorption. It depends on van der Waals force, and the higher the boiling point, the greater the amount of adsorbed gas. It is directly proportional to the amount of solid surface available. So the more the solid surface, so the higher adsorption can occur. For chemical adsorption, or you can call it as chemisorption, it is where the gas molecule forms a chemical bond with the adsorbent, with the material, with the surface. So gas is strongly held to the solid surface by valence force, and this is a quite slower process since displacement of atom must occur in molecules because they occur some reaction. So when we have reaction, of course, it will release some gas or heat and require more energy. So the process is irreversible, and the amount of gas adsorbed depends on pressure and temperature. Okay, for example, catalase reactions, chemisorption of carbon monoxide and also ammonia. Okay, so this is for regenerative carbon adsorption system. Okay, it uses carbon as the medium. Then the other one is non-regenerative carbon adsorption system. So the steam is used to purge captured pollutants. Okay, now look at the example for adsorbents, the medium. Key characteristic of solid adsorbent. The first one is preferential affinity. For example, alumina, activated charcoal, silicate, molecular sieve, zeolite. Okay, so these are examples for adsorbents. And then number 2, you have to look at the surface to volume ratio. Okay, it can be provided by the internal pores. It can be increased by activating some adsorbent. Okay, for example, activated carbon and activated alumina. It can be designed with fixed, moving, or fluidized bed. Okay, we have fixed bed where activated carbon is used. Moving bed. Okay, so the adsorbent is contained in a rotating drum. And then also we can use as a fluidized adsorber. Okay, as you can see in the lab. Okay, so adsorption and desorption, two types of adsorbers depending on gas property, whether easily dissolved or not, based on regenerative or non-regenerative. So if non-regenerative, it's very costly because once used, so cannot be used anymore. Kalau regenerative, kita boleh guna again and again. Okay, so example. Okay, next is absorption, also known as scrubbing. This is okay, some of the equipment you have seen before because it also can be used for particulate. So again, for absorption, the contaminated effluent gas, or known as absorbate or solute, is brought into contact with liquid absorbent, or known as solvent. Okay. So we can use water as the reactive or non-reactive. So the amount of gas absorbed depends on the properties of the gas and solvent, the pressure, temperature, and also the packing being used. Example, application of absorption, it can be control, SOX, NOx, and the other characteristic of solvent must have low freezing point, low intoxic, non-volatile, non-flammable, chemically stable, and inexpensive. Okay, these are application of absorbers to trap the gas contaminant. Okay, absorption unit, same as particulate contaminant we have learned before. Okay, spray tower, venturi scrubber, plate tower, or pack tower. Okay, so this is example for spray tower. Same concept as control devices for particulate contaminant. Okay, again, the advantages of spray tower: high efficiency for low concentration of gas contaminant. And disadvantages: less gas liquid interface area and less effective in removing gas contaminant, and good for particulate removal. This is example for plate or tray tower. You can also use the pack inside the tower in the form of tray. Okay, so this is how it looks like, the bubble cap tray in plate tower. Okay, this is example for pack towers. Okay, the packing used either in interlock saddle, ratchet ring, or pawl rings. The material of packing must be large surface to volume ratio, because large void ratio will minimize the resistance of gas flow, and also the material of packing must be lightweight and unbreakable. Okay, this is example for pack tower and plate tower. And next is Venturi scrubber. This one has been learned in particulate contaminant, how to control devices for particulate contaminant. The same concept. Okay, it has the Venturi throat, and then it has also liquid injection. Okay, number 3, for gas contaminant, it can be used condensation to control, and it has 2 basic types, surface and contact condenser. Okay, this is condenser example, surface condenser and contact condenser. And lastly, to control gas contaminant, combustion process can be used. For basic element to efficient combustion to occur, we need oxygen, temperature, turbulence, and certain time. Okay, to convert the air contaminant to, in the case, CO2 and water. So the product will be CO2 and water. So 4 basic elements for efficient combustion to occur: oxygen, temperature, time, and also turbulence. Okay, type of combustion, we have 3 types: thermal combustion, direct flame combustion, and catalytic combustion. Okay, so for direct flame combustion, it will produce flares. So this is disadvantage of flare, will produce visible smoke or soot. And next is thermal combustion, and then catalytic combustion. For catalytic combustion, it consists of preheating and catalytic section inside. So the efficiency depends on the contaminant concentration, the gas stream temperature, oxygen concentration, contact time, and also the type of catalyst being used. So normally it used to control SOx, NOx, hydrocarbon, and also carbon monoxide. So normally the catalyst being used is platinum. This is most effective for NOx. So palladium also can be used as catalyst, and also the ceramic materials. Okay, so advantages: lower temperature, and the catalyst reaction. The catalyst will accelerate the reaction to reduce time. And disadvantages of catalytic combustion: it requires high maintenance costs and also catalytic poisoning. Okay, so again, this is the equipment being used for certain diameter of pollutants. Okay, thank you.